Hello, everyone. I'm Robin Dale, and I'm the Deputy Librarian for Library Collections and Services at the library, and I want to welcome you all to the Library of Congress. What you're going to see today is a really special program. The Rare Book and Special Collections Division and the Geography and Map Division have brought together their combined collection of extremely rare and historically important early printed atlases based on the work of ancient Greek astronomer Claudius Ptolemy. Each of these rare gems, some printed in Greek and containing woodcuts, others in Latin and featuring intricate engravings, come from the very beginning of printing in the West. Today, they're on display together in one place for the first time. These books are spectacular works of both the printer's art and early modern science. Combined, they represent more than a century of collecting at the library across its many divisions, with the first example having been acquired in 1867. I want to thank Mark Dimunation, Chief of Rare Book and Special Collections Division, and Paulette Hessler, Chief of Geography and Map Division, along with her staff, for putting together this program. And I want to thank the members of the library's Lee Phillips Map Society and all of you watching along with us today, whose interest, generosity, and continuing support of the Library of Congress make acquisitions and programs like today possible. I now want to introduce John Hessler, a specialist in computational geography and geographic information science at the library. As many of you know, John has written extensively on early Greek and Roman cartography and teaches a course on these very atlases at the Rare Book School at the University of Virginia. He's going to speak to us this morning about the mathematics of Ptolemy, his complex philosophy of the natural world, and the birth of Western cartography in Alexandria, Egypt, about 2,000 years ago. John?
Thank you very much, Robin, and thank everyone for coming. I see a lot of faces here that I've seen in the Washington Map Society and the Lee Phillips Society, and I want to thank everyone else, both on the live stream and everyone here for participating in this event today. Like Robin mentioned, we are going to have an extraordinary display today in the Rosenwald room. And before that, I'm going to actually talk a little bit about Claudius Ptolemy. And I'm going to talk, as Robin also said, about the birth of Western cartography in Alexandrian Egypt almost 2,000 years ago. So the title of my talk, The Birth of Cartographic Reason, is a little bit different tact than we would normally take in a talk about historic atlases. This is not going to be a talk where I'm going to show image after image and explain each of the woodcuts to you. You're going to see plenty of those either on the live stream after my talk or in person in just a little while. But what I'm really going to do is really zero in on why Ptolemy is important. He's not important just because of the fact that he wrote a lot about cartography, and these are a bunch of old books. He really began an idea of what cartographic reason actually is. What is it to make a map? What does it mean to make a map? And what does a map say to us? It's just not simply a wayfinding tool. It's not simply a visualization of territory. There's a lot packed into this. And Ptolemy invented some very important methods. So we're going to start in a strange way, actually, with some modern mapping. And we're going to talk about a thread. And I'm going to try and pull this thread of cartographic thought from 2,000 years ago all the way to the modern map today. And when we're talking about the modern map today, we're talking about something very different than Ptolemy would have imagined. Maybe. I hope to convince you that that's not true. We're talking about something that suppresses time in Ptolemy's time. In other words, the map is a static object. Today, if you do GIS, if you do any kind of interactive mapping, what you want to do is you want to show dynamics. You want to show the temporal nature of the world. And Ptolemy wanted to do the same thing in his Geographia, and I'm going to show you why that's true. So if we look at maps of today, this map, for instance, here, which I just used in a congressional briefing, is the map of refugees flowing around the world over the last decade. It's a dynamic map. It's showing something a little bit different than just the static nature of the world. COVID maps. We've all been very familiar with the dynamics of this. This is a non-equilibrium process. This is not a static thing. We're seeing motion, we're seeing change. Ptolemy was also very interested in change. Even though he is making maps in the 2nd century, he's very interested in the temporal nature of time, causality, and space, and the interaction between all of those. And what I'm going to do for the rest of my talk is try and actually convince you of that, and also convince you that when you go up and you look at these atlases and you see these maps, I want you to look at them in a completely different way than you might have before. So cartography basically is what you are familiar with as a static map. It's a piece of paper with a map on it, or a digital screen with a map on it. It shows a piece of space, it shows an attribute, shows a building, shows whether you have broadband access, but it doesn't change. It's just a static thing. It's almost obsolete when it's made, because by the time you look at it, the world has changed around you. But cartography that doesn't consider the nature of transient phenomena suppresses the temporal. And in suppressing the temporal and in suppressing the 3rd dimension, it abstracts away from reality. And this is the root of cartographic reason, this abstraction out of a reality, to make you believe that you are comprehending a region of space when you might not actually be comprehending that region of space. It's a tool to simplify the world. And Ptolemy wanted to simplify the world in the 2nd century. He knew this. And this very concept, this concept of suppressing the complexity and visualizing it, is the nature of Western cartography and the nature of visualization in a cartographic sense. So Ptolemy begins. We first hear of Ptolemy, we first know of Ptolemy in an inscription. The inscription no longer exists, but he had an inscription put up in the town of Canopus in the 10th year of the reign of the Emperor Antonius, which is 146 to 147 CE, depending on whose calendar you think about. And in this, Ptolemy sets out the basic mathematics of the cosmos. He basically puts all the parameters in an inscription that would allow someone to determine the motion of the cosmos in a physical inscription, not a map, but a physical inscription. And this inscription doesn't survive anymore. But what does survive is copies of it that were handed down through time in manuscripts. And this is the first we hear of Ptolemy, this inscription in 146. So what he's doing here is he's basically sending out the kind of basics of how to map the earth, how to map the heavens in an inscription. This is really the first kind of document that we have like this from the Greek world. Before this, there are Roman documents that survive, but they're basically survey documents. They're basically about land surveys. Ptolemy is thinking of something different. He's not thinking about that kind of cartography. He's thinking about the world, the whole thing, not just surveying for practical means. Now, when you go up and you see those atlases, you're going to see lots of numbers in them. And Ptolemy used a different kind of numbering system, a sexagesimal system, which is a base 60. And he uses a notation. So when you look at this, and I'm not going to go into this in any detail, but just realize what you're looking at is a different way of numbering. And Ptolemy, even though we don't know much about his sources, and we'll get to that in just a bit, obviously had lots of access to Babylonian sources. He uses the Babylonian numbering system that's first seen on cuneiform tablets. And this is the way he begins to map out the world with these little tidbits, these little hints of parameters of the stellar world. Now, Ptolemy wrote 3 important books. One called the Almagest. That's the way it's come down through the Arab translations, but it's really in Greek mathematical syntax. It is something akin to an astronomy textbook, perhaps the most important or the most successful textbook in science ever written. It was the solid textbook for more than 1,500 years if you wanted to learn astronomy. He wrote the Geographia, which is really the central portion of what we're going to do today and what you're going to see today. And he wrote something called the Tetrabiblos. None of these separate from each other say anything too much in depth about Ptolemy's philosophy of nature and Ptolemy's philosophy of mapping. We've got to combine all of these together because these major works understand a universe in constant motion. They understand a universe where causal things happen for various reasons. And we're going to talk about the interplay of these 3 books, and you're going to see one of them, as I said, in the display or after the live stream. So What does the Almagest do? What does Ptolemy's astronomy try to do? Well, what it tries to do is it tries to capture in a book the motion of the universe. If I take Ptolemy's information and I animate it like you see here, Ptolemy's system, of course, he has the Earth in the center and not in motion. But everything he did with circles and geometry allows you to do this. He used something called an epicycle, which you see appearing on the screen, and using these geometric tools was able to predict the retrograde motion of the planets. So what we see here is we see an animation of his system in motion, moving. It's a book, yes, but it is about time. It's about things changing, constantly changing. He also wrote the Geographia. The Geographia, of course, like I said, is the subject of today's session. So what the Geographia is a textbook, a book about how to make a map. Now, you're going to see lots of maps, and people who are in map societies and tend to think about maps as just maps, standalone. But we don't even know if Ptolemy made maps. And I'll get to that in just a bit. But what he did is wrote a textbook on how to make a map. And one of the most important innovations of that is something called a map projection. So if you think of the Earth as an orange, and a map is peeling the skin off of an orange and trying to lay it out flat. Well, you can't do that without tearing the orange, without somehow introducing some kind of error in it. And what Ptolemy did is figured out a geometric way to think about that error, to understand that. And that is really the roots of Western cartography right there. You've got latitudes and longitudes and a grid that you put those on. And that grid somehow tries to give you some sense of the real nature of the Earth. But again, it abstracts from the reality. There were 3 projections in Ptolemy's work. One, the first, the second, and the third. And what we're going to concentrate on today is the second. When you go up and look at the display and you see the live stream, you're going to see all 3 of these displayed. We've picked pages so you can see the whole range of Ptolemy's work. The Tetrabiblos, so this is the third work, and this is the thing that draws the other 2 together. The Almagest, a model of the universe, so basically a model of the universe in motion. The Geographia, a model. Again, the word model. Ptolemy knew that it wasn't an exact model. Ptolemy knew that his Almagest wasn't an exact model. They were approximations, they were instruments, they were tools. The Tetrabiblos is something different. The Tetrabiblos is where he draws it all together. It's an astrological manual. It's a manual that depends on exact notions of where the stars and where the planets are moving through the zodiac at the time you're born. It also is a manual that tells how states and countries are going to develop, when a country is founded, when a first king is born. It's all put together. The motion and the place, the motion of the universe, the motion of time and birth and death on the Earth, all put together into a causal document. So none of these can be separated out from Ptolemy's basic philosophy of science and philosophy of the universe. And really, what you are going to be looking at today is a snapshot of that philosophy. Now, how did Ptolemy come up with this idea of making a map? Well, he did it with only a few tools. He only had a compass, a straight edge, a string, and a pencil. So he maps out a grid. The first thing you have to do when you make a map is you make a grid. But one of the things Ptolemy did is he wanted to somehow preserve ratios. In other words, he wanted to preserve the ratios on the Earth to the ratio on the map. So what he did is he used a globe, and he talks about the globe. He talks about using a globe, using a compass in order to look at how the lines of latitude change on the globe. And then he begins a geometric process. What you're looking at here is an animation that we did for a website called The Land Beyond the Stars, which is a combination of the Library of Congress and the Galileo Museum that we did several years ago. But Ptolemy built this up from a complex geometric construction in order to actually look at how the latitude and longitude lines, as many of the latitude lines that he could preserve as possible. And so that's how he began to build up his graticule. A complicated process. When you try and do it yourself, it really is an extremely complex process of really understanding the geometry of the space that he is working in, this idea of moving from a sphere to a flat plane. Now, the idea that a sphere can be mapped onto a flat plane, Ptolemy was the first one to really think it through. but he didn't really understand what he was doing. He didn't really understand that it was impossible to make a map be the same as a sphere. So in other words, when you talk about making a map, there is no possibility of a perfect map. You always have to introduce some kind of error. We can talk about equal area maps, which preserve area. We can talk about conformal maps, which preserve angle. We can talk about all of those things, but it's impossible to make a perfect map. But that wasn't proved until 1827, that it was actually impossible to make a perfect map. So Ptolemy, 1,000 years, 400 years beforehand, understood it, but didn't have the mathematics with which to actually prove it. But it wasn't proven until Gauss did it in 1827. So when we're talking about Ptolemy right now, I've been concentrating for the most part on the text. And we're going to continue talking about the text because you're going to see the pictures later. What Ptolemy wants to do is he wants to map the oikoumene, so in Greek, the whole world. And he wants to give you all of the knowledge that you need. So when you're up there and you're looking at these books, you're going to see a book which is trying to give you every piece of knowledge that you need in order to make a world map. He talks about world cartography. He distinguishes it from regional cartography and surveying. He talks about his sources. What are his sources? This is a real scholarly mystery. Most people think it was traveler's tales, but it isn't. Ptolemy tells you specifically that it's not. He tells you that it would be possible, perhaps, to make a more accurate map if he had better scientific observations, astronomical observations. In other words, from the place you are, looking at the stars, using the Almagest, using his models, using things called the handy tables, which were available for where the stars are in order to actually cite the position of a city or a place on the Earth. He tells us that's what he is actually using. When you look at Ptolemy's book, what you're going to see is you're going to see the majority of it is those tables. It is going to be lists of places, latitudes, longitudes, errors, places where rivers come out. It is mostly coordinate lists. And one of the amazing things is if you take those coordinate lists and you compare them with modern coordinates, you see two things. One, so if you look at this graph, the blue and the green up at the top, those are latitudes. Those are modern latitudes compared with Ptolemy's latitudes. Ptolemy is almost perfect when we're talking about latitude. When we're talking about longitude, he's very good also. But you'll see there's a gap. There's a gap between the modern and between the Ptolemaic. There's a systematic error in his measurement of longitude. It's consistent across the whole space. No one knows why. It's a question that remains open, so if any of you are in need of a project, it's probably a good place to start. I can send you some references. It's not a problem. He also says that the world changes, that time happens, that these maps are not static. These maps are temporary. These maps will be superseded very quickly, and that is just the nature of research. So he understands a lot about what we do as cartographers. He really has basically provided the base of everything that we think about as far as cartographic reason goes. Now, to talk about the Renaissance and to talk about the medieval period is to talk about the rarity of these books. Some of the great book hunters of the Renaissance period, some of those great men and women and collectors who collected manuscripts were always looking for Ptolemy. It was extremely rare. There are letters and letters about, I cannot find a single sheet of Ptolemy, but I want to. And this relates to the Geographia. The Almagest was all over the place, but the Geographia seems to have had a lot more rarity, mostly because, of course, it was a map. And as Ptolemy said, it was probably obsolete. Now, there's a bunch of recensions of this, and we're not going to go into this at all, but I want to just tell you that there's two families of manuscripts of Ptolemy. The earliest ones we have go back really to the 13th century. That's it. So we're 1,000 years from Ptolemy's time is the nearest we can get to him in an actual manuscript. There's two parts. There's one that is from the Byzantine world and one from the more European side of things. We don't really know. All of the atlases that you're going to look at, no one has ever really traced back from the manuscripts, the recension back into the actual atlases. We know they're founded on these manuscripts. We know they have a lot of the same things in common, but all of the books and all of the manuscripts tend to be fairly unique. So most of you, as I said before, have seen examples of Ptolemaic maps. They're not his maps, and they're not the maps of his contemporaries. The earliest surviving examples of maps in a manuscript of Ptolemy is 1100 years after his death. We are closer in time to those maps than he was. So they're quite a distance from him. There's a number of editions, and I'm just going to show a couple of pictures here to show you what kind of happened to the text. So we've got the manuscripts. They're kicking around a little bit. In 1577, or 1477, the first illustrated edition comes out of the Cosmographia. The Cosmographia is the same as the Geographia, just a different name. It's translated by Jacopus Angelus di Scarperia. It's a terrible translation. It's an awful translation. It's a beautiful book. It contained 26 copper plates. There's the first projection, as you all now know. That's what it looks like. Unfortunately, the one edition you're not going to see today is the 1477 edition, because it is the one edition that we don't have. So again, for the Phillips Society members and those who want to support the library, this would be a really welcome donation to our collections. So the next time you're searching through bookstores, if you happen to come across it, we would really appreciate it. So this translation, this Latin translation, gets a very bad review. Regiomontanus, one of the great astronomers who used Ptolemy's tools, writes about it. What will happen if the first copy has been rendered obscure by a careless translator or transformed by the first starving copyist who happens along? Both of these can be seen in the work that is today passed off as Ptolemy's Geographia, in which the literal structure intended by the Greek author does not correspond to the phrases written by Jacopus Angelus, who makes the meaning of words, and in which the appearance of maps do not preserve the appearance intended by Ptolemy. So again, we've got this distance, we've got this separation, we've got the manuscripts that are far away, we've got Ptolemy's book and the text that we know, but the maps are the things that people get excited about, but we have so little to go on their actual origins and what went into them. We can think of our own collections here. Martin Waldseemüller, the author of the great 1507 world map, writes a letter to Johannes Amerbach, the great Basel bookseller, and says, I think that you are aware that we are going to publish Ptolemy's Cosmographia, the Geographia. You're going to actually see two of those upstairs, one from Geography and Map in its original binding, and one from the Rosenwald collection that's beautifully colored. So Ptolemy's, or Waldseemüller is making this. And he says, as the exemplars do not agree, I am asking you to oblige me. In the Library of the Dominicans, I want to borrow a Greek manuscript. I want to collate this against something because the exemplars that I'm using do not agree. I don't know how to make a decision when I'm making this book. Also, what Waldseemüller does in his Ptolemy is he separates out the historic Ptolemaic maps from modern ones. He recognizes in 1513 that there is history and there is modern mapping. And he puts in something called the Supplementum, where he puts in a series of extraordinary maps of the Americas, which you're going to also see. The other thing he does in the 1513 edition is he begins to include Greek words. Here's the first time that we have Greek coming into the Latin translation. So that manuscript, that Dominican manuscript, whatever it was, the Greek words begin to filter in and next to the Latin manuscripts, next to the Latin words. We don't know what that manuscript was. No one has ever sat down and collated the 8,000 place names in Waldseemüller's 1513 Ptolemy. So again, if you need a project. This is one of the maps he includes in his supplementum. So we can see here Terra Incognita, we see Isabella, we see the coast of North America and part of South America. We see the first time in a Ptolemaic atlas these modern maps beginning to appear, and an extremely important thing. Waldseemüller also, in his great 1507 map, employs, now you all know, a Ptolemaic second projection. But he has a problem, a serious problem. The world is much bigger than Ptolemy. Ptolemy doesn't go 360 degrees, and he only goes 10 degrees below the equator. So Waldseemüller has to modify. And the way he modifies is that he tries to freeze it and stretch it. And you can see in the inset here that he actually kinks Ptolemy's little curves. Ptolemy's curves are perfect. They're beautiful geometric figures. But what Waldseemüller does to make the world fit is he squeezes the projection. He messes with the projection. And this is something that cartographers are going to wrestle with during this period. Another Ptolemaic atlas here, this one you're also going to see. This is from 1514, done by Johannes Werner. No maps, nothing at all. But what is in here is the extension, is how mathematicians and cartographers are beginning to think about extending that second Ptolemaic projection. On the left here, you see a perfect example of the construction of Ptolemy II that you saw in the little inset and in the little interactive. On the right, you see a few pages later where he has figured out how to extend this projection by moving the pole down into the view and into the mapping frame. And it is an amazing, amazing book, which, like I said, you will see. So to conclude, when you see a Ptolemaic map, when you look at it, when you try to understand it, think about it in a little different way. Ptolemy wrote those three books, the Almagest, the Geographia, and the Tetrabiblos, because he was trying to understand his world. He was trying to understand the complicated nature of his world, trying to understand how the stars move, how the Earth changes, how those stars affect what happens on the planet. Now, of course, we can talk about and discuss and argue with his idea of what causality meant. Obviously, we have an astrologer who's thinking that a lot of what's going on here is, because of the way things just happen to happen, where you were born, where the alignment of the stars were at that moment. But what he was doing is trying to understand his world, trying to come to terms with the complexity, and trying to abstract from it in a way that people could understand it. We do the same thing today. The people who are doing GIS, the people who are advising Congress, the people who are making maps showing Ukrainian refugee flows today are doing the same thing. We're taking these complicated, non-equilibrium, hard to understand processes, abstracting away some of the material and bringing it down to help us understand the way the world operates. I want to thank you all for coming, and I'd be happy to take questions. Couldn't have been that good that there's no questions, okay? There's got to be something, even if it's, you need a project. I mean, Tom.
You mentioned the 1477 edition. Where are there copies of that now, and do you think there are any more copies out there and available?
It's a good question. Okay, so the 1477 edition, there was one auctioned off a decade ago, maybe. The library attempted to buy that edition. We had raised somewhere in the range of $2.5 million. It was sold at Christie's, and it went for $6.9 million to a private collector. That was the only one that had ever come up at auction. I've never even seen a single sheet of the 1477 in dealer's catalog or at a fair or anything like that. So I don't think there are too many out there. As for how many there are, there's, I think, 11 that are known, so it's one of the rarest of them all. Part of that reason is, of course, the 1475, which is the first printing of Ptolemy. You'll see that upstairs, too. Doesn't have any maps in it. It's just a handbook. But the 1477 is the first one that has maps, quickly followed by the 1482 Ulm, which you will see, which is what you see on the screen here, the 1482 Ulm. Yeah, it's an open question. I don't think we'll see one anytime soon.
Hi. You had mentioned that geography and cosmography could be used interchangeably.
Yeah.
Do you know why that distinction started and why some are referred to as the geography versus cosmography?
That's a good question. But the reason really is the Geographia, the name of it in Latin and in Greek really is geographic method, okay? And it became Cosmographia because Ptolemy makes such a big stink in it about he's showing the world, he's showing what's known. And it just kind of, the translation between the two kind of was used interchangeably. Also, you'll see, and you'll see this upstairs in a little while, a lot of times both of these volumes are bound together. You've got both the Geographia and the Almagest, and comes together into the Cosmographia. You'll find that a lot of contemporaries with the maps that you're going to see in these atlases, like Waldseemüller, for instance, use the word Cosmographia. And there's a couple of distinctions that he's trying to make there, which really have to do with kind of disciplinary boundaries, trying to force geography into the astronomy realm as opposed to this sort of mixed science, give it a little bit more credence. But it's a complicated question. Yes. So, oh, go ahead, Dick.
Early, you quoted critiques of an early Latin translation. My question is, what was the point of reference? What was the origin against which this Latin was so heavily criticized?
Well, it's a couple of things. Where this was translated, Jacobus didn't know Greek very well. We're talking about a period in the West in the early 1400s, late 1300s, where in places like Italy and Venice and things like that, Greek is just beginning to be taught. We're thinking in terms of like Erasmus, and those guys have not yet really gotten going. So he's sort of an amateur Greek translator to a certain extent. And so also in the narrative portions of the text where there's no problem, where he's just talking about, okay, I'm going to make a world map, blah, 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 it's great. But where it gets problematic is the technical details. So it's obviously this problem between lacking certain technical prowess and lacking the depth of the Greek. So
The Greek original was available to others besides the translator.
Now, that's a complicated issue because the earliest Greek manuscripts that come down to us are from the late 13th, early 14th century. So we don't really have very much before that to go on. We don't have any original Ptolemaic text. We don't even have one that goes directly back to the original. So there's a couple missing things in the recension. So we've only got these two groups. So getting back to what Ptolemy had is also a difficult thing because we're also talking about an iterative process. We don't know what kind of latitude, longitude tables Ptolemy had. We don't know what kind of place names he had. Obviously, as time goes on, more places get added. So we have no idea. So we have a lot of distance. The one thing we do have and the one thing we do know is that we have the text because we have references to the text in many, many places. So the text is kind of the thing that we have. But you'll see upstairs, there's a lot of different interpretations of the maps, a lot of, you'll look at title pages and there'll be differences. But it's an interesting question. The history of the translation and transmission of Ptolemy is really a fascinating one and could be a graduate seminar on its own. Or either one, whoever's first.
Oh, I was just going to say thank you for your excellent presentation because you made me think about something with the astrology in that in modern times with science, we're pretty likely to look back on that concept and sort of make fun of it as being unsophisticated. But as a student of quantum physics, I really see overlays with the Lorentz butterfly effect. And just think it would be fascinating to go back and sort of apply some of those principles because maybe Ptolemy was really way ahead of his time in that.
What's interesting, since you're a quantum physicist, I will tell you that if you begin to model the Almagest, if you begin to model the planetary motion, so the video that I showed that shows the retrograde motion there of Mercury, that's actually based on Kolmogorov's quasi-periodic functions. So I didn't use Ptolemy because they model exactly. They also model certain aspects of the Fourier transform, this constant periodic motion, but it's a quasi-periodic motion. So there's a lot of sort of, it's not randomness, it's obviously deterministic, but when you put a lot of circles together and spin them around, you get a lot of different weird periodic effects, and Ptolemy obviously knew it because he was a master of it. There also seems to be some hints that, that certain Babylonian astronomers, certain earlier texts may have been playing around with the same thing, but there's a lot of that kind of things that you can do with the Almagest. The Almagest is still a fairly unexplored from a deep mathematical standpoint. There's a lot more going on there in the geometry that one can talk about. I mean, one could model some of it using sort of algebraic geometry at this point, things like the Borsuk-Ulam theorem. Now I'm going off on a tangent. So anyway.
Inspired me to go looking more.
My question is really generally on the life of Ptolemy, and why Ptolemy? Was there a spark that started him on this path, and what kept it going, and was there this super group around him that continued to feed it?
That is a phenomenal question. And the reason that's a phenomenal question is why only Ptolemy? Maybe not why do we only have Ptolemy? Why do we only have these Ptolemaic texts and not other major texts? And before Ptolemy, Ptolemy in his Almagest and in the Geographia hints at Hipparchus, hints at other sources, hints at other people. But his book was so well done, so perfect, that it was the one that was reproduced time and time and time again. So we don't really know what came before. There's, of course, the gap. We have Ptolemy, who wrote this book, we believe, in about CE 150. And then we have some 14th century manuscripts. What happened in between, we don't know. There's mentions, there's use of his geography, but we've got nothing to go on, really. So he was in Alexandria, Egypt. We know that was an intellectual center, an amazing place. He obviously had a certain amount of money. The canopic inscription that I started with as sort of the birth of Western cartography proper, was put up by him on a stela. So there's obviously something going on there, but we just have so little to go on.
Hi. How do you think about cartographers or map makers than against from Ptolemy? No? For example, Framauro is against to Ptolemy.
Right.
For example, the north put in the south, no, and invert the earth, no.
Right.
And he didn't use latitude and longitude, and it's interesting because he's a Italian cartographer or map maker. And how do you think about?
It's a fantastic question. Why were they going outside of the Ptolemaic form? What was the hope? What was the advantage? And when you look at some of those, and there's a number of people who will do that, who will not use latitude and longitude, and I don't really know. It seems to be, are they hoping that the method is going to be better? Are they hoping that the method is going to be somehow more convenient? This idea of latitude and longitude is a problematic one, obviously. I mean, at this period. I mean, no one can measure really longitude, on a ship or anything like that. You can measure it by looking at the stars. But is there a better way to compile this? And this points to a paradox in the Ptolemaic Atlas itself, which is Ptolemy tells you how to make a map with latitude and longitude. He tells you you're going to draw a grid and you're going to put these points on it. But he doesn't tell you how he's getting all these latitude and longitudes. He does say that he needs astronomy as the source. That's the best way to do it. He talks about Hipparchus going to cities and measuring the latitude and longitude and providing him only with a couple. But how does that all come together? And for those of you who are interested in this sort of period, one of the big open questions that we always have in the history of cartography of this period is, what are the lines of transmission of this knowledge? How does it get around? Dick Flederer sitting over here who spent his life studying, the movement of portolan charts around. How does that stuff move? Who moves it? Who decides what's true? What is a true longitude and what is a not true longitude at this period? What is the basis of that? How does that logic and that epistemology squeeze itself into the visual image? It's a huge, huge question.
Is an Arabic word. Is there any information in the Arabic tradition of Ptolemy?
Yes, tons. Most of the astronomical parts of this are certainly mixed with the Arabic tradition. The Arabic tradition saved many Ptolemaic manuscripts. There are many copies of the Almagest that were done in Arabic, even to the point where we have probably more brief surveys of it in Arabic than we do from this period in Greek, in manuscript form. So really when we talk about sort of Arabic science at this period, I mean, it really is this commingling. And really we are, before this, it was the Arabic and Islamic tradition that saved most of this material. So there's no question about that. When we look at Ptolemy's sources, he's also, really pulling from Middle Eastern sources, from not only Arabic sources, but older Babylonian sources, all kinds of things that he's pulling from. So it is a real document of a moment. And of course, it comes from Alexandria, Egypt. It's not coming from, which at the time is a Roman province, but it's still a Greek-speaking province. So, Ron.
John, I wonder if you can, I'm changing the thread of questioning here a little bit. Can you say a little bit about how the library built this collection? And how many of these different editions did Lee Phillips acquire?
That's a good question. Well, obviously, you're bringing up Philip Lee Phillips, the namesake of the Philip Lee Phillips Society. Philip Lee Phillips, in the interwar period, did a lot of traveling over to Europe, made collections of many, many of these atlases, which were then made into a bibliography and basically published. The collecting history, as far as I can tell, begins with the first one, which is the 1513 Waltzing-Muller Ptolemy. There's no records in the library of any reason or how it was acquired. The only way you know it's 1867 is, like all good libraries, on the front page, the library stamped it. Library of Congress, 1867. So there it is. It's acquired. So it didn't go into Mars, but it was acquired in 1867. And then it seems there's a real kind of slow, gradual accumulation, but Philip Lee Phillips probably is the substantial collector of the vast majority of these.
Were exhausted. So for those of us in the room who do advise both Congress and the executive branch, and we try to take information from our federal activity and visualize it, especially on maps, because it's so much, the power of information on maps is overwhelming. What helpful hints do you have? What are your go-to thoughts on how to convey data in a visual form or convey this type of information?
That's such a huge question. When one is creating a map, I really think for certain, right now we've gone past, I think, the static map as a useful entity. In other words, a map with a single layer that just shows, all right, here's a bunch of houses and here is, they have broadband service. I think we've gone past that. We've obviously gone past the use of a map for wayfinding with, whatever particular program you use to find your way around the world. You don't ever pull out a real map. It's just a data point being projected onto a map on your screen. So you're not using it for wayfinding. So when we're talking about using them for information, when we're using them to try and convince people, my way when I do it, when I'm making a map, simplicity to me is the best option. What I'm trying to say really is that I think about when I want the person to get out of it, what is the pedagogical outcome? What is the one thing when they look at this map I want them to see? So when we looked at it and I showed that Ukrainian, or the refugee map from around the world, I've suppressed almost completely any geographic names or anything. All you do is see the shadows of the continents and the countries. But you see this explosion of people. And I think it's like anything else. What is it you want to say? Say it simply and try not to confuse it with too many bells and whistles. Try and keep it to what it is you want to convey to the person. So that one, the colors start out orange and then they go deep red as they cross their country's border. So I'm basically trying to show, like, okay, something's really bad's happening, it's orange, uh-oh, they've crossed the border, this is really bad now. And then, so I think simplicity and somehow coming to terms with dynamics. You know, I really forced this thread with Ptolemy. You know, the maps that he made are not dynamic, but they're in pursuit of some sort of causal structure. I will just end this question by quoting William Warrants, who was one of the first heads of the Harvard Computer Graphics Laboratory, really the hotbed of where GIS began. He said, sometimes when a geographic event is too complicated and you can't describe it mathematically or by modeling, sometimes a map is the solution to the problem. That is the solution to the understanding. And I think if you think about it that way, sometimes the map isn't, sometimes it is. That's the way I always think about it, kind of in his terms. Okay, well, if that's it, I'm going to just say a couple of words. I'm going to introduce Mark Dimunation, and I'm going to just tell a little story. When I was an undergraduate, I took a class in medieval logic, and that was with the great classicist Jonathan Barnes. And Jonathan Barnes influenced me in so many ways about how important it was to look at these older medieval texts, to look at these books in certain ways, and to do a deep reading. I had never met anyone like Jonathan Barnes before. He was extremely dynamic. He could tell a story about a book like no one else could. That was until I came to the library and I met Mark Dimunation. Mark embodies everything that you would want in a rare book librarian. That humanist tone, the love of the arts. To hear him talk about the Giant Minds Bible, to hear him talk about one of Jefferson's books, or to hear him talk about one of the modern art printers that he so loves, is to have a world open to you. And I just want to introduce Mark Dimunation.
Well, that was astounding. Thank you very much. I think he did that just so it would make me stumble over my talk. First of all, welcome. We're very glad to hear you. I thought we had won John over to our side of the fence, that is book printing, because he was closing with comments by William Morris, a famous 19th century arts and crafts printer. It turns out that's not the same William Morris, so you're forgiven. But anyway, one of the things I think we've picked up in the questioning in particular is that these atlases are suggestive of many, many phenomena, and not just cartographic, but also transmission of text, transmission of ideas, the material culture of these atlases, and that's one of the ideas behind the gathering that we have here today. When Ptolemy published not only his maps, but also his method and his projections, or his ideas towards developing a system of projections, he was opening up a conversation, not only with the cartographers that preceded him, but those of the millennia that followed, in terms of understanding and shaping our understanding of the world. Today we have this opportunity, a really extraordinary opportunity. This is why we all hang around at the Library of Congress, is for these moments where we're going to have a large gathering of atlases that you're going to have an opportunity to look at. And they represent the transmission of Ptolemy over time and space, a considerable period of time and space. And we do this, of course, because it does help us understand the conceptualization of the world and a sense of location that these maps and volumes give us over time. But the Ptolemaic atlases represent much, much more than cartographic specificity. There's a truism in rare book curatorial circles that you can teach the history of printing with a single run of Bibles from the Gutenberg to the New Oxford. You don't need anything else in order to talk about how illustration and printing changes over time. And one could probably suggest that one could do equally so with a sequential run of Dante. I would argue you can do the same again with a run of Ptolemaic atlases. At least that's what we're going to find out in just a few minutes. So we do this today because we can find in these various editions the history of printing, how the art and craft of printing and illustration changes over time. We have the opportunity to gain insight from individual copies, unique in their former ownership, where annotations and corrections help us understand reception and change and how these ideas moved across Europe. And we do this because the notion of the sense of place in the world whether that be philosophical or spiritual or scientific, was made possible by these atlases. And, well, as we like to say here at the Library of Congress, we do this because we can. The staff of Geography and Map Division and Rare Book and Special Collections Division have pulled together a display of 33 editions of the Ptolemaic Atlas culled from our collections. We could have done more, many more. So we invite you to visit this extraordinary opportunity. It's on display in the Lessing J. Rosenwald room, which is LJ 205. You're in LJ. That's the Jefferson building, in the back of the building. It's located across the hall from the Rare Book Reading Room on the second level of the back of the building. There will be staff here that will guide you to this location. It's an interesting comment to make to a group of map people, isn't it? We hope to control, if we can, the flow within the room to about 20 people at a time, for this is the period we live in. So if we can, we like to keep it at that. We do have these books out on open display. So they're much easier for you to look at and to appreciate close up. And as Rare Book people, we understand the urge to reach out and touch, but don't do that. We'll be happy to show you anything you'd like to see from the materials. Staff will be there to help and answer questions if we can. The display is the conclusion of this event. So after you have visited the exhibit, you're free to roam the city as only a map lover would do. For those of you at home, who are viewing at home, we have made available a video presentation of the exhibition so that you too can participate in it. So thank you very much. If you'll follow the guidance of the people in the back of the room, we invite you to come join us in the Lessing J. Rosenwald room in the Rare Book Division to see an extraordinary display of Ptolemaic atlases.